So today we are going to talk about mole conversions. And when we talk about mole conversions, we are looking at different types of problems that are going to ask us to convert from one unit to a new unit. And so in order to do this, we are going to look at this resource that I call MoleTown in order to help us figure it out. You do have a copy of this, so please pull out your copy so that I can walk through it and we can talk about it together. So the first thing that I do want to point out are the 4 different units that are on this MoleTown. So the first unit that is on this MoleTown is going to be the one that's part of Mole Center. And so part of Mole Center is going to be moles. So MOL is going to be the unit that we are using for Mole Center. The next unit that we can see is mass mole. And the unit that's going to be associated with that is grams, which we signify with a lowercase g. The next one is particle part, and the units that lie under particle part are going to be atoms, molecules, or compounds. Okay, so those are all different words that you can see that are units that apply to particle part. And then our last one on here is volume village, and the unit that's associated with that is liters, which we signify with a capital L. So what we want to do is we want to think of this mole town as kind of like an actual town. The only way that you can get to the different parts of the town is by following the streets that connect each of the different parts of town. And so the way that we're going to use this is we're going to figure out where we're starting. So are we starting in Volume Village? Are we starting in Mass Mall? And then converting from one of the places to another place following the steps. So every time you get to a new circle, that's going to be another step that's part of your mole town. And then if we notice along the right hand or along the street signs, okay, the streets, we are going to notice that we have different conversion factors. So whenever you're going back and forth between moles and mass, you're going to be using the molar mass from the periodic table because the molar mass is equal to 1 mole of that substance. Whenever you're going back and forth between moles and volume, you're going to use the molar volume because that's equal to 1 mole of that substance. And whenever you're going back and forth between moles and particles, you're going to use Avogadro's number, which again is equal to 1 mole of the substance. So there are, for example, 6.022 times 10 to the 23rd atoms in 1 mole of that substance. If we're looking at volume, there are 22.4 liters of any substance in 1 mole of that substance. And when we go back and forth between moles and grams, this is the only one that will change depending on the compound or element that you have. And again, that comes from our periodic table. So what we're going to do is use this information in order to solve some problems. I'm going to walk you through it. So this first one we have is how many grams of CO2 are in 3.4 moles of CO2? So the thing that I want us to focus on is where we're starting and where we're going. So we always start with the number and the unit that are attached. So we're starting with 3.74 moles of CO2, and the question is asking for grams of CO2. So what we do is we go to our mole town, and we look at where we're starting. So for this problem, we were starting in moles, and it asks for grams. So because we're going straight from moles to grams, it's only one step because we're only going to one new circle. So what we do is we create a dimensional analysis train track in order for us to convert. So the way we do this is we set up our train tracks, the horizontal line being a division sign, our vertical line being a multiplication sign. So we're always going to put what we're starting with in our top left, so it's 3.74 moles of CO2. Now the way that these train tracks work is in order to get rid of a unit that we don't want to anymore, we put it on the diagonal because it's like dividing. So moles divided by moles is very similar to x divided by x, right? If you divide a unit by itself or a variable by itself, they equal 1, so they cancel out. So that's what we're going to do here. We want to get out of moles, so we put it on the diagonal. And then the question is asking for grams. Because it was only one step, we can go straight to grams. And so when we're here, this conversion factor, so right here, the top and the bottom numbers need to be equal to each other. We're always going to set moles equal to 1, and then we're going to figure out what needs to go on top or next to our other unit. So here, if we look, it says molar mass is what we use to go from moles to grams or grams to moles. And that's from the periodic table. So go to the periodic table, and we are going to add up the molar mass of carbon and 2 oxygens. Carbon has a molar mass of 12.01. Each oxygen has a molar mass of 16. So we're going to end up with a molar mass of 44.01. So what we do now is we multiply everything that's on the top and divide through what's on the bottom. So because we just have a 1 on the bottom, we don't necessarily need to divide. So we end up with 3.74 times 44.01, and we're going to end up with 164.6 grams of CO2. All right, next one. How many moles of O2 are there in 2.0 liters of oxygen? So again, we look at what we're starting with. So we're starting with 2.0 liters of O2, and the question is asking for moles of O2. So what we're going to do is we're going to go to our mole town, and I'm just going to clear a little bit of this for us. Okay, so we were starting in liters, so that's right here, and it asked for moles. So now we're going inwards, but it's still only one step that we're going, right? We're only going to one new circle. So we create a railroad track that only has one step, so one vertical line. We always put what we're starting with in our top left, so 2.0 liters of O2. Now we don't want to stay in liters, so the way that we get rid of it is putting it on the diagonal. And the question is asking for moles, so the units of moles goes on top. We're always going to put a 1 in front of moles. And then if we go back to our mole town, we see that 1 mole is equal to 22.4 liters. And so that will never change. So 22.4 liters. And that doesn't matter on the substance. So now we multiply across, get an answer, and then divide on the bottom. And so your final answer here should be 0.089, and the units are going to be moles of oxygen. All right, next one. Here it says how many atoms of sulfur are in 0.413 moles of sulfur. So here we're starting with moles, and the question is asking for atoms. So we go back to our mole town, and we are going between atoms, which is particle part, and moles. So again, that is only one step because we're only going to one new circle. So I set up a railroad track with one conversion, so one vertical line, and we always put what we're starting with in the top left. So 0.413 moles of S. Now, I don't want to stay in moles because I'm trying to get to atoms, so I put moles on the bottom to get rid of it. Now the question is asking for atoms, so that's what goes on top. I always put 1 in front of moles, and then I go back to my mole town, and I see that 1 mole is equal to 6.022 times 10 to the 23rd atoms, right? So that's the number of atoms that are in 1 mole of any substance. So that's the number that I'm always going to put in front of atoms. So make sure that when you're plugging anything with scientific notation into your calculator, you put that entire number in parentheses so that you give your calculator instructions on how to complete it. So I'm going to do 0.413 times 6.022 times 10 to the 23rd. And the number that I get in my calculator looks like this, 2.487086 e to the 23rd. Remember that this e means times 10 to the. So a correct answer here would be 2.49 times 10 raised to the 23rd, and then your atoms as your unit. Okay, last one. So here it says how many grams of water are in 3.79 times 10 to the 23rd molecules of water. So here we're starting with molecules, and the question is asking for grams. Okay, so it starts with molecules, and it's asking for grams. So here, it's actually going to be 2 steps instead of 1 step, because we first have to make it to moles, and then from moles, we go to grams, because we are going to 2 different circles instead of 1 this time. So what I do is I now set up a train track for 2 steps. Oops. The way that I do that is with 2 vertical lines. So I always put what I start with in the top left. So it's 3.79 times 10 to the 23rd, and that's molecules of water. Now, I don't want to stay in molecules, so the way that I get rid of that is by putting it on the diagonal. So whatever's on the top is always the next step that we are getting to. So if we go back to our mole town, our first step going from molecules, making our way up to grams, is going to be moles. So I put moles of water in my top step. Because moles is different than what we're trying to get to, which is grams, we now have to get rid of the moles unit also. So the way we always get rid of units is by putting them on the diagonal in the bottom. Now, my next step, so I'm here, now I'm trying to get to mass. So my next step is going to get me to grams. And so I put grams of water on top. I always fill my moles first because it's always 1. Everything is always equivalent to 1 mole of the substance. So now I have to figure out my conversion factor. So 1 mole of water is equal to how many molecules of water? So if I go back to my mole town, that is Avogadro's number, right? So I go ahead and I plug in 6.022 times 10 to the 23rd molecules of water. Now, moles and grams. I have to figure out how many grams are equal to 1 mole of water. So if I look going from moles to grams, that's molar mass. So I have to figure out the molar mass of water. And I do that by adding up 2 hydrogens and an oxygen. So each hydrogen is 1.008. Multiply that by 2 since we have 2 of them, plus 16. So it's 18.016. So in order to solve that, I'm going to multiply across and then divide by everything that's on the bottom. So go ahead and try that, and I'll put my answer up. And I get 11.3 grams of water. And that's how you do mole conversions.